Okay, today we're going to take it a little bit further with our naming, and we're going to look at how to name using complex ions. So if we look at your periodic table and look on the back side of the periodic table, you're going to see a bunch of different ions that have groups of elements in them. So more than just one. So far we've been looking at just binary ionic compounds, so where you have one metal atom as an ion and a non-metal ion. But now we can actually have groups of elements that are made stable by sharing their electrons and then gaining or losing some electrons as a group. So some of the common ones you may or may not have heard of before. Nitrate is one that's very, very common. It's nitrogen and 3 oxygens. And altogether, they're sharing their electrons covalently, but then also as a group of N's and O's, they've also gained an electron. Ammonium is another one. NH4, this is our major polyatomic positive ion. So you can call them complex ions. You can also call them polyatomic ions. Maybe I'll write that down. Polyatomic ions. Oops. And if you think about what that means, it means you have many atoms making the ion. That's what poly means. So unlike neutral molecules, these complex ions will have an electric charge with them. So it's important to understand, like if I write, and lots of students won't realize that this little charge makes a huge difference. So if I write something like NO3, that is nitrogen trioxide. But, so maybe I'll write that down. Nitrogen trioxide. But if I write it like this is a nitrate ion. That little charge makes a big difference. They are completely different things. So again, just like the subscripts, changing the subscripts changes the thing, changing the charge also changes it as well. So it's very important that we understand the difference between a molecule and an ion. These are molecules that have gained or lost electrons. And on the back side of your periodic table, you're going to see a whole bunch of different polyatomic ions. So I'm just going to flip to the back side of the periodic table. So here are all of your cations, your positive ions. The only one that is polyatomic or a complex ion is ammonium. So the way I remember ammonium is it's like ammonia, but it's got an extra hydrogen ion. The rest down below most are complex ions. Most of them are nonmetals because if you think about it, they are covalently bonded and then gaining an electron or 2 or 3 to form the ion. So here's acetate. Notice it can be written two different ways. We'll just more often than not write it in this form, Ce2H3O2-. This form will also tell us something about structure, but we can get into that when we get to organic chemistry. And just so on and so forth. So all of these ions. Now we're going to keep these or treat these as one thing. So like acetate here, C2H3O2, is the same idea as F-. It's treated the same. It's just a bunch of atoms that are all together having a negative charge. No different than fluorine by itself having a negative charge. So I'll show you what I mean by that. We'll go back to the PowerPoint. And here we are. So we're going to follow the same rules we've been doing all along, but we're going to treat that complex ion as a single thing. So naming with our complex ions. If we're going to write the name, this is actually, I'd say, the easier of the two parts because we just need to look up the name on the back side of the table. And I'm never going to ask you to memorize those. You will always get the ion side of the periodic table. So if you see some of these names, I should probably say, because there's some common names. On the back side of your periodic table, HCO3 will be called hydrogen carbonate. Another short form for it, or kind of more of a slang word for it, is bicarbonate. You might also see something like hydrogen sulfate, HSO4 with a minus charge. You can also call that bisulfate. That Bi prefix just stands for hydrogen. So an example of this is baking soda. If you look on the box of baking soda, it'll say sodium bicarbonate. Another possible name for it is sodium hydrogen carbonate. It's just trying to shorten up the name a little bit. So here are some examples of chemicals that contain polyatomic ions or complex ions. So when I look at these, I'm looking for metals and nonmetals. First of all, that will tell me that this is an ionic compound. So with NaNO3, I see Na is my metallic component, and NO3 is my nonmetal component. So this is an ionic compound, so we don't need prefixes, and we just state the elements that are there. So the first one is sodium. But this second part, this group here, this NO3, is a group of atoms that are making an ion. So I look up NO3 on the back of your table, and it's nitrate. So this would be called sodium nitrate. Looking at the next one, when I look at this, I see zinc is my metal, and ClO3 is my nonmetal, and that represents something called chlorate. So I'm going to write down my two elements here. So the first element is zinc. Now, zinc is a transition metal. It could have Roman numerals. It almost always has a 2+ charge. Actually, it always has a 2+ charge. So it's always zinc 2. We don't need to say zinc 2. We can just say zinc. And then we look up ClO3 on the back of our periodic table. So I'm going to switch to our periodic table. Here it is. And let's find ClO3, and it's this guy. So that is called chlorate. So we're going to call that zinc chlorate. How do I know it's the ClO3 minus? Well, because when you break this down, you're going to get 2 positives and 2 minuses from there. Okay, let's do the next one, PbSO4. So Pb is lead. Again, when I look at this, I see my metal, and then I see my nonmetal group. So there's my 2 parts. Now, lead is a transition metal. We'll do the charge in a minute. SO4, if we're not sure, let's take a look. SO4 is over here, and that is called sulfate. Now, again, notice that there's 2 ways to spell sulfate, or sulfur even, and sulfide. It's either PH or F. I believe PH is the Canadian spelling, so that's what I'll use. So it's going to be lead sulfate. Now, depending on the charge on sulfate, that will tell us the charge on lead. So sulfate is a 2- charge, and there are 2 of them. So I have a total of 4 minuses, so I need 4 pluses from the lead. So this would be lead 4 sulfate. The rules that we had still count. We're just applying it with complex ions. Okay, so give yourself a minute and try, actually before you do so, I keep forgetting to fix this. This should just be NH4Cl. There should be no 2 there. So I'm going to actually rewrite it, NH4Cl. So give these ones a try, and then I'll put the names up in a second, and you can see how you did. So looking at this one, you'll notice that it's all nonmetals, but we did see this as a complex ion earlier. So that's going to be my metal part, and this is my nonmetal part. So this is still an ionic compound. And if I look up NH4 on my periodic table, it's a positive ion, and there it is there. It's called ammonium. So now I'm going to call this ammonium, and then chlorine is going to be chloride. The next one, I'm looking at Na is my metal, and here is my nonmetal group. So my metal is sodium, and HCO3 off of the back of the periodic table is hydrogen carbonate. Another way you could have written this is sodium bicarbonate. Now, the next one, actually, and I'm just to remember, we talked about this a minute ago, that's baking soda, which is the same thing as sodium hydrogen carbonate. Now, the next one is magnesium. So I see my metal, and then I see this big complex group here. That's my nonmetal. So I'm going to write down magnesium first because I know what that is. Magnesium. Now I'm going to try to figure out what C2H3O2 is. So I'm going to go here and let's scroll down because it'll be the negative ion. Oh, there it is. It's acetate. So we're going to call this magnesium acetate. And that's how you name with complex ions. Now to go the other way with the formula, to get the formulas, we're just going to have to do this whole thing in reverse. So if we need a subscript, like if we need more than one sulfate or chromate or acetate, we need to use brackets. You can actually see that we did use brackets here. And that's so we'd have 2 acetates. And that's just it. We're going to treat these complex ions as one thing. So if we're trying to find the formula for barium sulfate, we look up barium on our periodic table, and barium is in the column, second column, so it's Ba with a 2+. Then we look up sulfate on the backside, SO4 2-. So if I want to put these together, it literally just becomes BaSO4. I don't need more than one of each because they already add up to 0. But if we do aluminum, so aluminum is Al, and it's in the third column, so 3+. Then we look up hydroxide, and that's OH with a minus. Now we treat this as one whole thing with a minus charge. So to get 3 minuses, I'm going to need another OH and another OH. So I'm going to need 3 OHs. So I'm going to write it like this, AlOH3. But notice I had to put brackets there. Now I have 3 OHs, because if I didn't put brackets, it would look like this. And right now, that 3 is only applying to the hydrogen. So we want 3 OHs, so we have to do it like so. Okay, and then the last one is iron 3 sulfate. So the nice thing with the iron is they're telling me the charge, so this is a 3+. And sulfate we already did earlier, but I'm going to look it up again. It's SO4 with a 2-. So now we need to put these two things together. The lowest multiple of 3 and 2 is 6. So to get 6 positives, I need another iron. To get 6 negatives, I need a couple more sulfates. So now I have 6 positives, 6 minuses. So the formula would be Fe2, I need 2 of those, SO4, 3. But to have 3 of them, I put the sulfate in brackets. We don't need to put brackets like here in this first one if there's only one sulfate. You don't need brackets there. It's a kind of a waste of time to write them. So give these ones a shot and just pause the video, try them, and then restart the video and you can check your answers against mine. So for the first one, copper is a 1+, so I put Cu with a plus. Then we look up phosphate, PO4 with a 3-. So to make this match up, I'm going to need 3 copper. So Cu3+, Cu3 plus and PO4 with no, we only need 1 PO4. Barium bromate. So we look up barium. Barium is a 2+, and then bromate. Ooh, I forget that one, so I'm going to look it up. So bromate is there, BrO3 with a 1-. So I'm going to write that down. Pen, there we go, BrO3, 1-. So to make this match up, I'm going to need 2 of these guys. So it's going to look like this, BrO3 brackets 2. And then the last one is magnesium. So magnesium is Mg, and that's a 2+. It's in column 2. Hydrogen sulfate. So if you're not sure, we look it up on the periodic table. So hydrogen sulfate is HSO4 with a 1-. So HSO4 with a 1-. So I'm going to need another HSO4 1- to add up to 2 minuses. So the formula would look like this, MgHSO4 brackets 2. And there's your formula for magnesium hydrogen sulfate. Notice we didn't need prefixes because we have charges to work with. So only covalents need prefixes. After that, we just use the names that we've been given and the charges we have.